Hi there. So I just want to talk about this inquiry a little bit. So I started here with just this is just a light bulb I found in our box of household light bulbs we've got. I think this goes in, and we have a bathroom in the back. These go over the top of the mirror. Also, I had some night light bulbs, and I had some regular light bulbs. And one of the activities in the electronics book is, hey, uh, take a battery like this, like a 9-volt battery, stick this thing on the negative, and I'm going to have trouble with this, and this is going to be one of my points, but if I attach this end here, and I'm not even going to try and do a good job on this, but here, and imagine that's securely attached, just pretend, okay? And then here, um, that could potentially light the light. Now you see it isn't doing anything, but right, it makes a loop. It has the light interrupts the circuit, and I have positive here over to negative here. So why doesn't that work? And it doesn't work for any sort of household bulb. It turns out that most household bulbs need 120 volts. That is way too much for really anything on the scale that we're working on. It took me quite a bit of experimentation to see that. And you see in the book it says like get a specific type of bulb, but yeah. So that's one thing. So first of all, keep that in mind. You need the voltage on the output devices that you're working with to match the devices here. Okay. So the next kind of contraption, kind of in this theme. So this is the household objects theme. So I'm giving up on the standard light bulb, and I just have a 3-volt LED in here. So again, that's another thing to pay attention to. So it turns out that the LEDs, that each color is associated with a different voltage, and or tends to be. And in this case, the yellow is 3 volts. So a single AAA battery, so that's also an important conclusion, isn't going to light up any LEDs potentially if you just grab a handful of LEDs at your local store. If I look at this, like obvious, so I had to put 2 here in series, so 1.5 plus 1.5, that's 3 volts, which is enough to light it. Now, right now it's not lighting. There you go. Okay, so it does work. So yeah, but it's very temperamental and irritating. Okay, there you go, nice and bright. Okay, so in this one, there was a lot of debugging here, getting this thing to work. This thing actually took me a surprising amount of time to get going. So, an advantage is that this is something that the students can relate to. These are all everyday household objects. Something like a flashlight as part of this, I did take the top off a flashlight. I started thinking about it that essentially all flashlights have the 2 batteries in series like this. That must be to be enough current to light the light, and even then, like a flashlight battery is going to be the same as a household battery. I almost smashed an existing flashlight we had into pieces to get the bulb to put that in here to verify that that would work. I'm sure it would. I decided not to destroy the flashlight to do that. But obviously the relatability of these materials, it's something Pepper likes. And these are still the same basic categories: the power source, conductive material, output source. So along the way here, I had a lot of trouble with the multimeter readings in this one. For whatever reason, I would just put the little pieces of tinfoil here on either side of this, but then get a reading that there wasn't any current, which was surprising and confusing to me. Still not sure what was going on with that. Like again, the fact that one battery won't light up anything. And it's just tough working with a tinfoil. So just like physically tough, just electrical tape and tinfoil. It's annoying to make sure that everything gets connected the way it should be. All right, so that was that one. I actually did discover a lot, right, about different kinds of power sources and LEDs and stuff from doing that one.